All right, let's take a look at these examples. So the first one in your notes, example number 1, is the combustion of 3.50 grams of ethanol in a sophisticated calorimeter. So I like to draw these out, especially at the beginning when you're still trying to kind of visualize what's going on here, is to think in here you have 3.50 grams of ethanol. And it's going to be burned. So this is an exothermic reaction. So by looking at this, I can see, oh, the temperature of my water is going to increase. And it tells me that the amount of water out here is 3.63 liters of water, and that its temperature initial was 19.88 degrees, and its temperature final is 26.18 degrees Celsius. So there's the information that I'm given, and what they want me to find is the molar enthalpy. So I'm going to start by knowing, remember in the last lesson I said always ask yourself 2 questions. Is this temperature or chemical? Well, in this case, it's both, because they're talking about the combustion of ethanol and they're talking about the temperature change of the water. So in that case, whenever you think it's both, they're asking and talking about both things happening, then I start with calorimetry. Heat lost is equal to heat gained. Now I have to decide how much to expand each side of that so that I can do my calculations. So if we start on the temperature change side, if we look here, they've given me the mass of the water, they've given me the temperature change, and since it's water, I know its capacity. So I'm going to expand that side all the way out to mc delta T. On the heat lost side, the chemical reaction, they've given me the mass of the fuel, not moles. So I'm going to need to use mass over molar mass delta HM is equal to mc delta T. So remember to always keep straight in your head though. Everything on this side is for the ethanol. Let me clean that up a little bit. And everything on this side is for the water. So don't get this mass confused with this mass, because the one is the mass of ethanol and the other is the mass of the water. So we can start to fill this in now. We know that they give us 3.50 grams of ethanol, and then below that I need the molar mass of ethanol. So take out your data booklet. Remember that ethanol is C2H5OH, and if you forget, you can draw it out like we learned in the organic unit. But go ahead, take a second, figure out that molar mass, and then unpause the video. All right, so you should have got 46.08 grams per mole, and the question is asking me to find delta HM, so I don't have to fill that in, that's my unknown. On the water side of things, I know the mass of the water. They've given me 3.63 liters of water. Now, if you remember that 1 milliliter equals 1 gram, you can also, by doing conversions, say 1 liter will be 1 kilogram. So I can either say that I have 3.63 kilograms, or I could say that I have 3,630 grams. I'm going to use the kilograms and demonstrate to what I was talking about yesterday with changing the capacity. So 3.63 kilograms of water. I know the capacity of the water is 4.19, but in this case, because I have kilograms, I'm going to use kilojoules per kilogram degree Celsius. So now those kilograms will cancel. And then if I look at my temperature change, I went from 19.88 to 26.18. That's a change of, getting a little crowded here, 6.3 degrees Celsius. So if I take this now, I need to get the delta HM, this unknown, I need to get it by itself. So everything else needs to move across the equation. So I'm going to divide by 3.50 grams so that that cancels. And I have to do that to both sides, so that cancels there. Now that's on the bottom on the other side, and to get rid of the 46.08, I would times by 46.08 grams per mole. That's going to cancel with that. So over here, I would have to put that on the, well, I'm really crowded now, that's going to go on the top. So that's another times 46.08 grams per mole. So in the end, what you should have is delta H equals 3.63 times 4.19 times 6.3 times 46.08. And then all of that's going to be divided by 3.50 grams. So if we go through and figure out our units, this gram will cancel with the gram here. My degrees Celsius will cancel with my temperature. And in the end, the only units I'll be left with are kilojoules and per mole. So my answer is going to show up in kilojoules per mole, which ends up being delta HM, a 1261 kilojoules per mole. Now there's two things you have to remember. Number one, this is not significant digits because all the values above only have 3 significant digits. So I would change this to 1.26 megajoules per mole to get my significant digits by switching my metric conversion. And because it's exothermic, I have to put in that negative. So remember, the second question I said you always have to ask yourself is this losing or gaining heat? So anytime you solve for a delta H or a delta HM, you have to think about in the end that symbol right there. Should this be a negative number because it's an exothermic reaction, or should that be a positive number because this is an endothermic reaction? All right, let's try one more. So example number 2, you have 2.65 grams of sodium hydroxide is added into some water. And we have 20.0 milliliters, oh not water, sorry, of hydrochloric acid. The temperature of the solution goes from 25.0 degrees Celsius to 29.4 degrees Celsius. And they want to know the molar enthalpy of neutralization for NaOH. So their molar enthalpy, they're looking for delta HM. So I have two things going on. I have a chemical change with the acid reacting with the base, a neutralization, so that I do have chemical change, but it does tell me that this is warming up as well. So I also have a temperature change. So just like in the last one, I start by saying that the heat lost should be equal to the heat being gained, and then I expand this out. So on the water side, I have the mass, I know the capacity, and I know the temperature change. So I'm going to expand out to MC delta T. On the other side, I have a mass of sodium hydroxide, so I'm going to use mass over molar mass. Delta HM is equal to MC delta T. So a very similar setup to our last example question. Okay, the mass of the sodium hydroxide is 2.65 grams, and I'm going to need the molar mass of that so that I can solve the problem. And the molar mass of that is 40.00 grams per mole. Okay, so there's my mass over molar mass. Delta HM is what I'm trying to solve. And I know the mass of the water is 20 milliliters. So in this case, I'm going to leave that as 20.0 grams. which means my capacity this time needs to be 4.19 joules per gram degrees Celsius. So just remember, if you're going to change that, it either has to be here, it has to be joules and grams, or it has to be kilojoules and kilograms. You got to make sure you keep those straight. And the temperature change here is, what is that, a 4.4 degrees Celsius. So to move things around, I need to move the 2.65. It's going to go down here, grams, and up here, I'm going to add in the 40.00 grams per mole. A little crowded, but hopefully you get the idea. So if we look at these values here, I have this gram is going to cancel with that gram, degrees Celsius with this, the grams on the bottom here with the 40 grams per mole, and I'm going to be left with joules per mole as my answer. So if I calculate this all out, I would go 20 times 4.19 times 4.4 times 40, and then I would have to divide by 2.65. So once you calculate that all out, you get 5,565.58, and that's joules per mole. Again, not significant digits because my question only has 3. Now don't get confused here. I wrote this down as having 4, but it doesn't matter what, that's a number I calculated. All the original numbers have 3, so my answer has to have 3. So instead of joules, I would change this to 5.57 kilojoules per mole. And this is warming up, I can see right here. So that means it's an exothermic reaction that's causing the water to warm up. So this is a negative number. So delta HM is negative 5.57 kilojoules per mole. So there's the examples. It's just taking the things that we learned yesterday and combining them all together to get the combination to work. So I know this can be a little bit confusing, but if you're having any trouble, just let me know. And make sure that you're good with those two separate formulas, your Q formula for temperature change, your delta H for chemical change. And then this is how you put those together in any kind of condition where you have both, where a question talks about temperature change and chemical change. This is what you'd have to do to solve it.